Hi everyone, welcome to another video. Today we are going to talk about multiplication of polynomials. So when we have two or more polynomials, we have in general three methods to multiply them. Method number one, array model. And we are going to use the following example to explore this method. So let's say we have two polynomials like this. X plus 2 times 3x squared plus 5x plus 1. So what we would like to do is to sort of make a table or an array. So we have x and positive 2 right here, which is basically the two terms in this binomial. And we want to have the three terms of the second trinomial right here. So 3x squared, positive 5x, and negative 1. So now we want to multiply them just as a multiplication table. So we would like to multiply this and x and 5x and x and negative 1. So if we multiply x by 3x squared, we would get 3x cubed. X times 5x is 5x squared, and x times negative 1, we will get negative x. 2 times 3x squared, we will get 6x squared. 2 times 5x, we will get 10x. And 2 times negative 1, we will get negative 2. So, what could we get from this table right here? The array model will tell us that the result of this multiplication of these two polynomials would just be the sum of all the monomials we get inside this array, which would be 3x cubed plus 5x squared minus x plus 6x squared plus 10x and minus 2. Now we can just combine like terms. And let's recall that a like term is just two terms. They have the same variable and the same exponent on that variable. And the coefficients of those two terms may not necessarily be the same. So, do we have any like terms for 3x cubed? We will see that no. So we just write it down here. Do we have any like terms for 5x squared? Yes, we do have a like term for 5x squared, which is 6x squared right here. So we combine these two terms, we will get positive 11x squared. Do we have any like terms for negative x? We do. We have this 10x right here. So if we combine these two terms, negative x and positive 10x, we will get positive 9x. And then this constant term, there's only one constant term. So, based on this array model, we will get that the result of this x plus 2 times 3x squared plus 5x minus 1 is 3x cubed plus 11x squared plus 9x minus 2. Next, we will be talking about distributive property. So what is distributive property? So, distributive property. So let's take a look at a simpler example, an integer multiplication. So, if I have 2 times 3 plus 8, what could we do? We have two ways to solve this. Way number one is we evaluate the bracket first based on bad math, this order of operation. So, we can do 3 plus 8 is 11, and 2 times 11 is 22. But we have a second way, which is utilizing this distributive property. Distributive property says that if we have something like a times b plus c, which is equal to ab plus ac, so we can distribute this a to the both terms in this bracket with the same sign separating them. So if we have 2 times 3 plus 8, which is 2 times 3 plus 2 times 8, which is 6 plus 16, which is still 22. So this is distributive property. So how can we utilize this property to multiply polynomials? So let's take a look at an example. So let's say we have x minus 3 times bracket 3x squared minus 4x plus 1. So we still would like to distribute each of the terms inside the first bracket into each of the term in the second bracket. So first, let's distribute the first term in the first bracket, which is this x, to the 3 terms here. And by saying distribute, we mean multiply. So we want to multiply this x to 3x squared to negative 4x, which is the second term, and to this positive 1 right here. So by multiplying x with 3x squared, we will get 3x cubed. And x times negative 4x is negative 4x squared. And x times 1, positive 1, is positive x. Now, after distributing the first term, which is this x, to the 3 terms in the second bracket, we would like also to distribute the second term, which is this negative 3, don't forget the sign, into the 3 terms of the second bracket, which is to multiply negative 3 to 3x squared to negative 4x and to positive 1. And because we do have a negative sign here, so it's a bit more challenging. So negative 3 times 3x squared, we will get negative 9x squared. Negative 3 times negative 4x, we will get a positive 12x. And negative 3 times positive 1, we will get negative 3. So, what can we get out of this? Still, we simplify by combining like terms. So there's no like terms for this cubic term, so we just write it down. Do we have any like terms for this squared term? We do, right here. So, negative 4x squared minus 9x squared, we will get negative 13x squared. Do we have any like terms for this x term? Yes, we do, which is this positive 12x. So we will get, combining those two, we will get a positive 13x. And we only have one constant term here. So we just write down. So, utilizing distributive property, we can get the result for this multiplication of polynomials is 3x cubed minus 13x squared plus 13x minus 3. And after that, we will talk about the last method when it comes to multiply 2 or more polynomials, which is called binomial multiplication, also called the FOIL method. So, as we can see in the name of the method, this strategy is specifically designed for binomial multiplication. So how can we utilize that? So first, let's take a look at what does FOIL represent or stand for. So FOIL stands for first, outside, inside, and last. So let's take a look at a specific example to understand how does this FOIL method work. So let's take a look at this example. So this is a multiplication of 2 binomials. Each bracket has 2 terms. So how can we use binomial multiplication? So first, as we can see, we want to multiply the first term of both brackets. So we use 2x times x, we will have 2x squared. Next, outside. So we want to multiply the outside terms of these two brackets, which are 2x and 4. We multiply them and we will get a 8x. Now inside. So we want to multiply the inner term of the two brackets, which are -1 and x, which gives us a -x. And lastly, we will calculate last, which is the last or second terms of both binomial, which is -1 and 4, which gives us a -4. So first, outside, inside, and last. Multiply the terms in that order gives us a 4 terms addition. So we can combine like terms, and this would be the result of this binomial multiplication. Let's take a look at a relatively more challenging example. So what if we have 3 binomials multiplying together? Would the same strategy still apply? So the way we do this kind of multi-polynomial or multi-binomial multiplication is to multiply 2 of them together first. So let's try to multiply the first 2 binomials together first, then deal with the last one. So still we apply this FOIL method. First, x and 2x gives a 2x squared. Outside, x and 3, which is a positive 3x. Inside, -2 and 2x, which gives us a -4x. And last, -2 and positive 3, -6. And the last term, or the last bracket, we just copied down. And then, let's simplify this bracket, this bigger bracket here first, by combining like terms. So we can combine the middle 2 terms together, gives us a -x and -6. And we have a binomial at last. So now it becomes the multiplication between a trinomial and a binomial. So how can we calculate that? Do we still use FOIL method? It may not work because FOIL method only works for binomial multiplication. So all the brackets are binomials. But now one of them is trinomial, which is not binomial, which makes us can only choose either array model or distributive property. So let's practice both in this one to see if both of them get the same answer. So first, let's try using array model. So we still make a table like this, and we have x and -1 here, which are the 2 terms of this bracket, and 2x squared, -x, and -6, which are the 3 terms of this trinomial. So x times 2x squared gives us a 2x cubed, x and -x gives us a -x squared, x and -6 gives a -6x. -1 and 2x squared gives us a -2x squared, -1 and -x gives us a positive x, and -1 and -6 gives us a positive 6. So now we can just add all these inner parts we get from the multiplication of the corresponding terms in the 2 brackets. And we should get the final result. So it will be 2x cubed minus x squared minus 6x minus 2x squared plus x plus 6. And then we combine like terms. There's no like terms for this cubic term. Do we have the like term for this square term? Yes, we do. We have this term right here. So -x squared minus 2x squared, we will get -3x squared. Do you have like terms for this -6x? Yes, we do have a like term here. So negative 6x plus x, we will get negative 5x. And last, we have this constant term right here. So this is the result of the multiplication of this trinomial and this binomial, which is the multiplication of these three binomials right here. So we get this. And next, let's try distributive property to see if we get the same answer. Okay, so let me copy this down. So by using distributive property, we want to distribute each of the terms one by one. So we multiply the first term in the first bracket to the first and second terms in the second bracket, and the second term in the second bracket with the two terms in the second bracket, and the third term with the two terms in the second bracket. So each term in the first bracket will be multiplied to the two terms respectively in the second bracket, and then we add them up. So let me just separate these two methods right here. Okay, so by multiplying 2x squared and x, we will get 2x cubed, 2x squared and negative 1, negative 2x squared, negative x and x, negative x squared, negative x and negative 1, positive x, negative 6, positive x, negative 6x, and negative 6, negative 1, positive 6. So next, by combining like terms, so we will have 2x cubed, because there's no other like terms for this cubic term, and we can combine these two terms right here. We will have negative 3x squared, and we can combine these two terms right here. We will get negative 5x, and this constant term we just copied down because there's no other constant terms. So we will get 2x cubed minus 3x squared minus 5x plus 6. And we will see that the answer we got right here is exactly the same as what we got right here. So we can see that both of these methods can be used to solve the multiplication between a trinomial and a binomial. And if we come by a binomial times a binomial, we can use FOIL method. Let's do a little summary right here. So when we are doing multiplication of polynomial, we have three methods. Number one, array model, which is when we make a table like this and we list all the terms of the two polynomials respectively down here, and we multiply them correspondingly, and then we add everything in the inner part up, which will gives us a result. And second, we have distributive property. And the principle of this property is based on A times B plus C equal to AB plus AC. And this can be extended into A times B plus C plus D. We can have multiple terms inside here. AB times plus AC plus AD. We just distribute or multiply this A into the three terms inside the bracket respectively and separated by the sign. And the third one, we have our FOIL method. And this method is specifically designed for binomial multiplication. So FOIL stands for first, outside, inside, and last. So when we have something like A plus B times C plus D, which is equal to first A and C plus outside B times D times inside B times C, and last Oops. Sorry. Let's do this again. So, first, the first two terms, AC, outside is the outside of this two brackets, which is AD. Inside is the inside of the two brackets as a whole, right here. So BC, plus last, which is the last terms of the two brackets, which is BD. So A plus B times C plus D equal to AC plus AD plus BC plus BD. So these are the three methods we learned in this video. Thank you very much for watching and have a good day.